We're going into chapter 1.3.1 of the Hine textbook. This is material you should already know. Now, what we're going to be talking about in this video is something called tuples, which I found that students feel less familiar with than sets. It's something that the math department tells me you should know, but let's go over it a little bit more slowly. So in short, think of a tuple as something that is very much like a set, except that order matters. The order that items appear in your tuple does matter. You can have duplicates, and we keep track of them. And we're going to use these regular parentheses rather than curly braces. So for example, we might have the fact, here's an old fact that you should know, the set ROWAN is exactly the same as the set containing the elements NOWAR, that's fine. But if you have a tuple with ROWAN in it, that is not the same as the tuple with NOWAR in it. Of course, we know this is a tuple because of the parentheses there. Because order matters, and the elements in this tuple do not appear in the same order. And sets and tuples are different beasts. You never have a set equal to a tuple. Okay. Some terminology, we will often call a tuple with just two elements a pair. Otherwise, we might call it a two-tuple. Similarly, a tuple with three elements, we might occasionally call it a triple, but usually it's a three-tuple. And then we just keep going. This is a four-tuple, and you can have a 27-tuple and a 56-tuple if you want. Another thing that you should also be familiar with is the Cartesian product of two sets, or the cross product of two sets. You start with two sets and you produce a new set of pairs. So a new set that contains elements, each element of which is a two-tuple. So if we look at the definition here from the book, if A and B are both sets, then the Cartesian product of A and B, which is denoted by this notation A cross B, is the set of all ordered pairs AB such that the first element is an element of A and the second element is an element of B. And here's the formal definition of that. For example, if we have two sets, the first set contains three elements, R, O, W, and the second set contains two, A and N, and I take the cross product of those two sets, I end up with this. Notice that I have a set, and every element in my set is a two-tuple. So I have 1, 2, 3, 4, 5, 6 elements in here, which makes sense because it's all combinations of elements from the first set and the second set. But of course, order in here does not matter. So this set is exactly the same as this one, right? I just moved around a couple of the elements. But either way, we have a set with 6 elements, and both of these sets are equal, so therefore this cross product equals both of them. All right. Here's a couple more examples. So if I take a set containing 4 elements and cross it with a set containing 1, I end up with 4 different combinations. Again, I'm just going through them and taking an element from the first, matching it with all of the second. In this case, we only have 4 things. And if you take the cross product of a set with the empty set, well, you take one item from the first set and one item from the second set. Oh, but there are no items, so the cross product of anything with the empty set is just the empty set.